So in this one, we've got two particles that moving along the x-axis at t is equal to 0. So we've got a particle is initially at x is equal to 4, and its velocity is given as 4t minus 6. The second one has a displacement of x equals 2t minus 2. So find the equation of displacement for the particle m. So we start with our velocity at 4t minus 6. So again, we need to integrate back to its position. And it starts initially at x is equal to 4, so t is equal to 0, x is equal to 4. Our constant then would be 4, and there's our position statement for particle m. When do the particles meet? Well, if they must meet at the same time when they're at the same position, so we make sure our x's are equal to each other. Solve them simultaneously, bring it all across, solve it. Solve that quadratic. We get t is equal 1 and 3 from our quadratic factorization. So that's where the two particles meet, at those 2 points. In question 13, we've got a velocity of a particle given as 3 cos 3t. Particles initially 2 meters to the left of the origin, so t is equal to 0. X would be equal to minus 2. So what's the acceleration after pi on 6 seconds? So we derive velocity. Minus 9 sine of 3t. And substitute pi on 6 and get minus 9 meters per second squared. So the displacement after pi on 6 seconds, we need to integrate the velocity. We get sine of 3t plus our constant of integration. We substitute t was equal to 0. It was initially 2 meters to the left, so it's minus 2. So that gives us minus 2 equal to sine of 0, which is 0, plus the constant, so it's minus 2. So when our function is that, and when t is equal to pi on 6, we sub it in. So that gives us sine of pi on 2, and sine of pi on 2 is 1. Minus the 2, it's 1 meter to the left of the origin at the end.